Hey everyone. Okay, today we've got solving equations 3, and this is where we're going to throw our doozies at you. So what we're going to get into today is going to have a little bit of review, so it'll give you a chance to see how well we're doing with solving equations so far. And then we're going to jump to some pretty ugly stuff. So at the end of today's lesson, seriously, look back and see what you did at the beginning or were capable or comfortable dealing with at the beginning of today, and just see like how far we came. Okay, to start things off, we're going to deal with a couple review problems. We're going to go through some things that will allow you to check your understanding, but also are going to allow us to maybe talk about alternate methods to be able to solve some things. So what you see on the screen right now is our instruction to solve, and that is going to be our instruction for the entire lesson. You have the equation given in question A. I want you to go ahead and solve that as fast as you can go. Okay, this one should be pretty automatic for us. Okay, pause it now. Okay, we are back. So I am hoping that as we worked our way through, I would have had a bunch of people say, okay, I'm going to expand in my 4 to be able to go through and simplify the left side. Now I need to isolate my variable term, so I need to get rid of that minus 12, so I'm going to add 12. I then need to get rid of my times by 8, so I'm going to divide by 8. That gets my variable all by itself, and there's my solution, x equals 3. Okay, I would expect to see those 3 lines on your page. Doesn't mean you need to have them, you could have had more, but that would have been a pretty standard solution for that problem. What I'd like to walk through, though, is an alternate way to solve this problem, because there is something pretty special in the problem. Now, I don't mean special like, ooh, this is very particular. No, but what I mean is there's an operation that's being done here that I want to make sure we look at in depth. So I'm going to put an alternate solution over in blue off on the side. Because what I'm going to do is I'm really going to break down what was on the left side of that equal sign. That is, it says that I have 4 multiplied by this whole thing. And I'm just going to put a little statement in so you can see why I'm able to do what I'm going to do. I'm going to let, I don't know, let's say A. There's no A's in that equation, so if I picked a symbol of A, it's nowhere else. Okay, that's a safe symbol to use. I'm going to let A equal 2x minus 3. So wherever I see the expression 2x minus 3, I'm going to replace it with an A. And what I would then have is the 4 times 2x minus 3, so it's times A, equals to 12. And I just want you to see that if you were given the equation 4a equals 12, everybody's action should be the exact same. We should be dividing out that 4. Let's get the a all by itself. So your first line would be 12 divided by a equals 3. Well, I say to you, well, there were no a's in our equation. So what did the a represent? And you say, oh, well, the a represented 2x minus 3. Well, then what we need to do is we need to sub a equals 2x minus 3 back into my equation. And so I get 2x minus 3 then is equal to 3. All I did was replace my a with what it was equal to. So my a became 2x minus 3. And notice you have a simple equation to solve. Okay, get your variable term all by itself. Get your variable all by itself. And we come in on the same solution. Okay, so we get the same answer. That should be at least a little bit to draw the conclusion that what we did was correct mathematically. You also then have our notation to show that, well, what we did was just use substitution. Okay, I'm going to get rid of all of that. So pause or rewind and go back if you need to get any part of that down. But that should now be justification for maybe rather than expanding, I chose to divide out that 4 first. Okay, well, how do you get rid of a times by 4? We divide by 4. 12 divided by 4 is 3. Well, now let's go ahead and get the variable term all by itself and get the variable all by itself. That's what your alternate solution could look like if rather than expanding, you chose to divide out the 4. Okay, that's just a different way to solve the problem. But I want to also draw to your attention that we have to be so careful about what we do. The only reason I was able to do that blue solution was because the 4 was multiplied by the whole 2x minus 3, by everything on that side. If it wasn't, then I can't do what I just did. So let's take a look at where we have a multiplication in there, but it's not times the whole side. And so we can see then where we would go wrong. In fact, let me just take that first blue line. So imagine that I had my 2x minus 3 equals 3. And I said, hey, I have a times by 2. And so now what I want to do is I want to divide by 2. Let's get rid of that times by 2 and let's divide by 2. So I'm going to divide my other side by 2. That means my times by 2 is gone, and then I get a 3/2. Well, at the very least, we should be able to see why there's no way that that's going to be a true solution. Because even if I was to get rid of that minus 3 and now add 3, I'm going to get a common denominator, but I almost don't even care. Because I know that my solution should have been 3 for x, and if I take 3 and I add something to it, I'm clearly not going to get 3. So my mistake in the red was that when I chose to divide by 2, I didn't divide every term by 2. I only divided the x term and the 3 by 2. I divided the x term by 2, that's why it disappeared. And I divided the right side by 2, you can see it on the 3/2, but I forgot, and I didn't divide everything by 2. Okay, I'm going to get rid of that red, because you could have worked your way through and did that. Okay, I have my 2x minus 3 equals 3, and I'm going to divide every term by 2. Okay, 2x divided by 2 is x. 3 divided by 2, I have to leave it as a fraction. Doesn't divide evenly. 3 divided by 2, okay. Well, now to get the x all by itself, I have to get rid of a minus 3/2, so I need to add 3/2. Hey, 3/2 plus 3/2 is 6/2, and 6/2 is 3. We got down to the correct solution. Because when we chose to divide out, we divided properly. We divided both sides by 2. I just have no clue why you would want to do the green. Like, why would you want to introduce fractions if you could have avoided it? So if we look back at the original expression, because that 4 was multiplied by everything on that side, that's what allowed me to divide it out first. Okay, I hope everybody can see that they can work through that gold solution perfectly fine. But to have that blue solution in your back pocket can help you at times. And to understand the green solution is going to be where we go with some stuff. And if you fully understand what we talked about in green, then I think you're going to avoid mistakes that we'll make later on. Okay, let's jump into another review problem. Okay, I want you to take a look at B and C. And I think B and C provide a great little practice quiz for us. B should be feeling pretty comfortable given your practice from previous day. C should look somewhat similar. I think it's going to have a little extra quirk to it, but it's not a bad one. I think that'll act like a good problem-solving situation. Okay, I'd like you to work your way through B and C as if they were a test. Start to finish, get down what you can, and we'll go through and see how well we match up. Okay, pause it now. Okay, we're back. So let's go through and let's confirm some stuff on B. Okay, I think it would have been a really good instinct to simplify both sides. So let's go ahead and let's expand our brackets. Both sides are simplified. Now we're trying to isolate our variable term, which means we need all of our variables on one side and our constants on the other. So I'm going to picture everything going to the right side. Okay, all my variables on the right side. So if I do that, I'm going to have a 15y, and then to get rid of a plus 8y, I need to minus 8y. So there's my 7y. To get that all by itself on the right side, I have to get rid of that plus 10. So to get rid of a plus 10, I need to minus 10. And now to finish off the problem, to get rid of a times by 7, I divide by 7. There we go. Okay, I would have had some people, though, that after that line, they might have still been in a mode where they're going, hey, I don't care. This is a test. I have to make sure that I get this right. I'm still making some mistakes every once in a while with the positive coefficient thing. I'm going to play it safe, and I'm going to go variable on the left. No worries. Instead, you would have had your 8y, and you would have had to now subtract 15y. What that would have meant for the other side, though, is you already had a 10 over there. To get rid of a minus 12, you needed to add 12. And now when we divide out, we're going to make sure that that negative is either on the top number or on the overall fraction. No one wrote the negative on your denominator. And there we go. Okay, 2 different options on how to go through and solve B. I am hoping that one went well, and I think that should give you great feedback as to whether we're getting enough practice done and we have a grasp of our stuff from our lesson. Okay, C, I said it added a little bit of a snag. And maybe you encountered that snag when we went through. Okay, I see I've got that 4x out in front. I'm going to expand that into my brackets to simplify. Well, first off, I really hope that everybody expanded in a 4x to an x properly. That's going to give me a 4x squared. Now I multiply my 4x into my negative 3. Can't do anything with that 2. On the right side, I can expand in my 2. And what you'll notice then is both sides of my equal sign, they're already simplified. On the left side, I can't put x squared terms with x terms because they don't have the same exponent. Both sides are simplified. So what we try to do then is to collect all of our variables into one term. And what we really like about this is regardless of what side you try to put your variables on, your x squared terms cancel out. Like just for instance, if I tried to put my variables on the left side, then I'm going to have a 4x squared, and I'm going to have to get rid of this 4x squared on the right. So to get rid of a positive 4x squared, I need to subtract it. So on the left side, I'm going to have a minus 4x squared, and there's where we see 4x squared minus 4x squared, those cancel out. Nice. So I'm going to get rid of even writing all that down, and you can see that they cancel out by my green slashes through those terms. So if I was to simplify it then, I actually get that equation after I collect my x squared terms. And this might be one where we just keep going with the variable on the left, regardless of the fact that it has a negative coefficient. Because now when we divide out, I would love it if we were able to jump straight to negative 5/6. That is, we see that we're going to have my 10 divided by negative 12. My answer has to be negative. And we can recognize that 10/12 has a common factor of 2. It will reduce the lowest terms, and therefore we write it in the simplest form. Okay, hopefully you can see why question C had a little bit of a snag to it. But we should feel relatively comfortable with both of those. And I think if you now add all 3 of these first problems in, they'd act like a very good practice quiz. Question A, pretty automatic, first day's work. Question B, there's our equation 2 work. And C was a little bit of a problem solving. Notice it's all based on the same theory we talked about. It just looked a little different. Okay, here's where now we're going to make our move, our switch into equations 3. So we're going to tackle some stuff that's going to start to look pretty ugly. Here we go. Okay, so now let's take a look at D, and I'm going to argue that we're getting into something that looks a little uglier. Like that is, when we encounter this problem, what's contained in the equation shouldn't be an issue. That is, if we took like a big picture kind of focus, I have a variable term on one side, a variable term on the other side. I have a constant on one side and a constant on the other. Like, we've dealt with that before. That looks an awful lot like question B. So we're used to having variables and constants on both sides. What makes this one a little uglier is I got fractions everywhere. So depending on comfort level, this might really cause us to have to hit the brakes. And what I want to do is I want to walk through different ways to be able to solve this equation. So we're going to go through this one together. And I'd like you to get down multiple ways to solve the equation. Don't just kind of look and predetermine, ooh, I like that way best, so that's the one I'm going to get down. I think the theory of seeing it multiple ways is going to really help us. Okay, what I'm going to do is I'm going to walk through this problem the same way we would have in the past. That is, we get all of our variables on one side, we get all of our constants on the other, so we can isolate our variable term. Okay, that means that I'm going to get my variables on the left side, and maybe even right now, like we're not even thinking about, well, which side would have a positive coefficient or not, because of the nature of fractions, that might slow us down a fair amount. But I then just go, okay, variables on the left. Well, if I do that, then that means I need my constants on the right. And so I'm going to put in one line of just getting those terms on the correct side of the equal sign. So on the left side, I would have already had my k. I'm now going to get rid of a plus 1/4 k, so I minus 1/4 k. I already had the 1/2 on the right side. To get rid of a plus 1/3, I subtract 1/3. So we come in on that red line. Now, on the left side, I have to collect my variable terms. And I don't think it's that big of a challenge for us to say that I have 1k and I'm going to subtract 1/4 k. Therefore, I have 3/4 k. That is, I don't think it's that big of a struggle. We might have been caught off guard by it, but we quickly kind of think, hey, 1 subtract 1/4, that's 3/4, not too bad. However, what if those values, the coefficients on your k's, were a little uglier? I want to walk through how you would represent that if you couldn't come to your simplified fraction in one step. So I'm going to get rid of that 3/4 k, and I'm going to keep another red line in there. What it would be is this. I have my 1 from in front of this k, my 1k. And then I have my subtract 1/4 from in front of this k. So really what I'm calculating is 1 subtract 1/4, those, or whatever that value is, represents my coefficient on my k. I need to put brackets around it, because if I didn't include the brackets, can you see that my expression now looks like I should just be multiplying the negative 1/4 by the k. I need to make sure that I have brackets around that whole thing to denote that whatever that value is my coefficient on k. Then what I end up having on the right side is a common denominator I need to get there. We should be pretty automatic that my common denominator is going to be 6, because that's 3 minus 2 of them, as I change my tops the same way. Okay, on the left side, let's imagine now that my numbers were really ugly and I couldn't get my common denominator and just go. Okay, well then I can be slow and methodical and say, well, I'm going to get my common denominator of fourths, because that would be 4/4 subtract my 1/4. There's my coefficient on my k. On the right side, we could simplify that down to 1/6. And finally, we get to a point where we have 4 subtract 1, there's your 3/4. 3/4 k equals 1/6, and we finally got down to an isolated variable term that was fully simplified. Okay, well, we could finish this problem off, hopefully pretty quickly. We do, though, have a bunch of different ways to think about it, so let's go back to what we've talked about before. The shut your brain off and go would say, hey, I have a times by 3/4, and so to get rid of a times by 3/4, then I'm going to divide by 3/4. So k becomes 1/6 divided by 3/4. And now my right side becomes all about me reducing my fraction divided by a fraction. So I get my 1/6, and I now multiply that by 4/3. And maybe my brain's really off and I don't look to cross reduce, and I get to 4/18. And now I go, oh, okay, I can reduce that fraction, divide top and bottom both by 2. Okay, you've got a lot of work there to get down to that solution. I'm going to get rid of most of that gold now because, as I said, that was your brain off sort of approach. That I would hope that for us to go through and solve for k in that instance, we would simply deal with opposite operation. I have my 1/6. Now, to get rid of a divide by 4, I would need to multiply by 4. So I can automatically write in my times by 4. And then at the same time, to get rid of a times by 3, I'm going to divide by 3. And we could at least come in on that line a little earlier, of which now I could go through and hopefully cross-reduce, divide a 2 out of that 4, divide a 2 out of the 6, and simplify that thing all the way down to k equals 2/9, and there's our final solution. Okay, I want you to just take a look at that solution in its entirety, because I want that solution to be our fallback, that I could just treat that equation as if the values in the equation were like any other values. And so I can just get my variable terms on one side, get my constants on the other. Who cares if they have ugly values? Okay, I'll just slow down and I'll do my calculations, and eventually I'll get there. You can kind of tell by the lack of enthusiasm in my voice, like that is a fallback, almost like brain dead method. That's the way we want to think about that. That's the way we want to feel about it. Okay, what I would like to do is I would like to tackle this problem a different way. And I think I might win you guys over to this. But in order to tackle it this different way, I'm going to have to rewrite out the question. So all I'm going to do is I'm going to jot that question out over onto the right. And so really it's a k plus a 1/3 equals 1/4 k plus 1/2. Because what I'm going to do is I'm going to mark up the question. So what I'm going to do is I'm going to take a look at that problem, and instead of just treating all numbers as if they are the same, I'm going to look for details in the numbers. So when I take a look at that equation, I notice I've got fractions. And if I think back to my fallback method that you can see on your screen, the red and the gold, okay, it's going to take me a few more steps because the numbers were uglier, they were fractions. And I want to avoid those extra steps. I want to be as efficient as I can be. So what I do when I look at the fractions, I have to view those fractions as the operations they are. And I notice that those fractions only come by because of these divide-bys. And I know that to solve equations through isolating, I can get rid of any operation I want by doing the opposite operation to the other side. And so if I just see fractions as divide-bys, then I can get rid of any divide-by multiplying. So what I'm going to do is I'm going to multiply and get rid of my fractions. Now, I'm going to put a bunch of stuff into that problem. So let's just examine at one point this first divide-by that we have, this divide by 3. Well, for me to get rid of that divide by 3, I would have to multiply by 3. I'm going to go back to the base definition of what an equation means. We see the equal sign in the middle, and we know that that's a scale. We know that this left side has to have the same value as this right side. By definition, that's what equal means. And so if I go to do any operation to one side of my equation, I must do the same operation to the other side to keep my equation in balance. So when I look at that green and I say I want to get rid of my divide by 3, I am going to multiply by 3. What I have to do is multiply both sides of my equation by 3. So I'm going back to the basic definition of an equation. Okay, what's that going to look like then? Well, it means that I'm going to take a 3 and I'm going to multiply it to the left side. And then I'm going to take a 3 and I'm going to multiply it to the right side. I hope that we can see that I did the same operation to both sides and therefore my equation is still true. Okay, why did I do that? Well, because when I now go to expand in my 3, that second arrow is going to eliminate that fraction. So when I expand in on the left side, I'm going to get a 3k plus, well, 3 times 1/3 is going to give me 1. And notice, I just eliminated my fraction on the left side. So I love that. Like that got rid of one of my fractions. Just notice that when I expand in my 3 on the right side, though, I'm going to get 3/4 k plus 3/2. It did nothing to fix that problem. So I really did like multiplying by 3 because it eliminated one of the fractions. However, maybe there is a better value to multiply by that would allow me to eliminate all of my fractions. So if we're good with the theory up to that point, then what I want to do is get a little closer to the way I would solve this problem. So what I'm going to do is I'm just going to erase everything that I just wrote down, including the equation, and I'm going to copy that equation out again because, as I said, I'm going to mark up this equation. Okay, so let's examine this equation as if it's the first time we're looking at it again. I see that I have fractions in there, and I go, ugh, I don't want to be slowed down by fractions. If something causes me a snag, then I don't run from it. I attack it. So if fractions slow me down, then I'm going to attack those fractions. All fractions are divide-bys. So I'm going to attack all those divide-bys. That means I'm going to multiply. But rather than just focusing on one number, I'm going to take a look at all three of my divide bys. And I can just take them in their bits. Okay, the first thing I can look at is I can say, well, how do I get rid of a divide by 3? Well, that's nice and easy. I can multiply by 3. Good. I'm not going to multiply by 3 yet. I'm just formulating a plan here. I know that multiplying by 3 will get rid of that divide by. But it won't have any impact on this divide by 4. So for me to get rid of that divide by 4, I'm going to have to multiply by 4. Now, take a look at my two blue numbers. Because if I was to deal with a multiply by 3, then a multiply by 4, that would be the same thing as me multiplying by 12. So right now, if I multiplied by 12, then I would eliminate this divide by, and I would eliminate this divide by. Nice. Okay, well, if we look back up at the original equation, I still have a divide by 2, and so this becomes a little bit of the snag. I would have some people that would then say, well, hey, to get rid of this divide by 2, I'm going to multiply by 2. And there's nothing wrong with that, like that's incorrect. But what it would mean then is we would have to multiply this 12 by another 2 and get us up to 24. We're going to multiply every single term by 24 to get rid of all of my divide bys. And I'm going to argue to you, why? Look at what I just put up in red. And I hope you can see that my red is unnecessary. Look back at my gold. Couldn't I just multiply by 12? Because doesn't 12 divide by 2 evenly? Yeah. That multiplying by 12 actually takes care of the 2 as well. Okay, why? Because if I took 12 and I factored it using my good old factor tree, I can see that a 3, a 4, and a 2 are all factors of 12. There's my 3 taken care of. Both of those 2's come together to give me a 4, and any one of those 2's take care of the 2. Now, had you chosen 24, that will eliminate all of your denominators, all of your divide bys. However, it just means you're going to work with numbers bigger than what you needed to, and you will guarantee that you're going to have to reduce your fraction in the end. But if we pick the best number to multiply by, that is the 12, then we might get to avoid all of that. Okay, for anybody who's a little puzzled still on that whole divide by, I think it's going to become a little bit clearer when we actually solve the problem the way we would. Okay, so I'm going to get rid of all of that stuff again and mark back up my equation. Okay, we're not quite at the way that I would actually solve this, but we're getting closer. We recognize to get rid of a divide by 3, a divide by 4, and a divide by 2, the best number to multiply would be 12. So what I would do then is I would multiply both sides of my equation by 12. But I actually don't write that. Because how many terms do we have on the left side of the equal sign? We have 2 terms. 1, 2. And so when we multiply that by 12, we're going to have to expand in our 12. Which means I actually multiply both terms by 12. Hey, I do the same thing on the right as well. Okay, so now what we're doing is we're getting closer to the way I would actually solve the problem. What I do is I put brackets around each individual term, and now I multiply each term by 12. I hope we can see that by multiplying each term by 12, I've multiplied both sides by 12. Okay, now what I'm going to do is I'm actually not going to multiply. I'm going to do the division first. Okay, what am I talking about? Let's just take a look at this second term on the left side. So if I just wrote out my 12 times 1/3, then we should be good that we could cross reduce and say, hey, 3 goes into itself once and into 12 4 times. And so we could go through and we could multiply that 12 times the 1/3 and get just 4. Right? Nobody's going to write 4 over 1 because we know 4 divided by 1 is just 4. And I'm going to write a huge boo on your page, so we can just write 4. That act of cross-reducing is what we are going to use here. Okay, so now we're looking back up at the blue, and what we're going to do is we're going to go through and actually solve this equation the way I would. Okay, what I'm going to do is I'm going to go across every term and simplify each one. Okay, so I'm going to deal with this first term. Well, that's 12 times k. There is no divide by, so I can simplify that one pretty quickly and say, okay, then that is 12k. Well, now I look at the next term, so I'll just kind of underline that one in gold. I have my 12 times 1/3. Well, what I'm going to do is I'm going to reduce it first. 12 divided by 3 is 4. So now what I have is 4 times the 1. There's my 4. Okay, I'm jumping to the right side of the equal sign. I'm now going to deal with the first term on the right. Well, now I can do my 12 divided by 4. That's 3. So 3 times 1 times k gives me a 3k. And then I deal with my last term, my 12 times a half. And that, my 12 divided by 2, gives me 6. 6 times 1, and there we go. Notice all of my fractions multiplied out. They're all gone. I have no more denominators, and I really love the look of that blue equation now. Now, before we finish that thing off, let's just make sure that there's nobody going, hey, look, that all worked out well. Gee, I wonder if it will always work out so neat. Yes, it'll always work out so neat. Because didn't we pick 12 knowing that that number would divide evenly by all of my denominators? Remember, we picked that value for that reason. So now let's take a look at the blue equation you have, and that one should be like the easiest of easy equations. Let's finish it off. To get rid of your plus 3k, we're going to minus 3k. To get rid of your plus 4, we minus 4. To get rid of a times by 9, I divide by 9. And I'm going to bet that I have a lot of people that really like that blue solution better than the red and the gold one. So when we take a look at this process, I do want you to notice that it isn't quite that simple. Like, it isn't just the blue equation on the right. You can see all the work that we did up top within the original equation. So really, what does it kind of become in my mind? The left equation, the red and gold one, like, that's really where I don't do any work early. And I just start plugging through and trying to solve it. So it means that I've got a lot of work to do throughout solving the equation. However, my blue solution, I think, is kind of the opposite. That is, I put a lot of work in early, but that saves me so much work later on. And I think that as time goes on, you guys are going to love that blue method. Put in a little bit of work early, and then you can fly through solving the rest of it. So the idea I want you to have in your mind as we go is, if you see fractions and you go, ugh, fractions are going to slow me down, then let's attack the thing we don't like. Let's multiply out, get rid of all of our fractions, create something that's nice and simple, and then we should be comfortable to fly through the rest. Okay, what we're going to do is we're going to spend our time for the rest of the day solving equations with fractions in them. but we should be able to go quite a bit quicker than what we've gone through on question D. Okay, here we go. Okay, you take a look, and I've thrown 2 more equations at you. I still want to walk through this together on E, and then I'm going to kind of let you go a little bit. Okay, let's take a look at E. Let's kind of tune out F. So on question E, I notice I have some fractions. And I say to myself, I want to get rid of my fractions. Fractions are divide-bys, so I need to get rid of divide-bys by multiplying. So I need to get rid of a divide by 2 and a divide by 3. Those are my only divide-bys. So to get rid of a divide by 2 means I multiply by 2, and to get rid of a divide by 3 means I multiply by 3. So I say to myself, well, what number has a 2 and a 3 in it? And that would be a 6. So if I multiply every term by 6, then all my divide-bys will be gone. So what do? I take brackets and I put them around every single term to remind me to multiply every term by 6, not just the fraction terms. If I put those brackets around everything, I won't forget. And now what I'm going to do is I'm going to multiply by 6, multiply by 6, multiply by 6. I've multiplied every term by 6, therefore I've multiplied both sides by 6. My equation is in balance. Okay, now I'm going to go through and simplify every term. Okay, there is nothing to simplify in the 6 times 3. There is no divide by. However, there is something to simplify here because I have my fraction. So I am going to divide my 6 times 2, or 6 divided by 2, and get a 3. Okay, I move to the right side of the equal sign. There is no divide bys there. I now work on my last term. There is a divide by. So 6 divided by 3, there's a 2. What I just did in the green, I just got rid of all my fractions. Now all I have to do is just simplify every term. Okay. 6 times 3 gives me 18. Minus 3 times m is a negative 3m. Equals 6 times 5 is 30. And minus 2 times m is a negative 2m. And there we go. Nice. No more fractions. No slowing down. Okay, I want you to go ahead and finish off that equation as fast as you can, and I mean fly. Pause it now. Okay, we're back. So I'm hoping that everybody was thinking about putting all your variables on the right side. Because to get rid of a minus 3m, I'm going to add 3m. 3m minus 2m is an m. That means I have to put all my constants on the left. So I'm going to have an 18 minus 30. That gives me a negative 12, and I am done. Look how fast that was. That was beautiful. If we had just accepted the fractions within the equation and slowly worked through common denominators and so on, there's no way you're dealing with that quickly. Okay, I think we're at a point where we should be able to give F a shot and feel somewhat confident in F. I'm going to lead you through the process. Okay, we get down the equation to F. You look at F and you see fractions. You have divide bys. So look at your divide bys and try to figure out what one number would be the best number to multiply by to get rid of all of your divide bys. Okay, I'm hoping we have that number. If you chose 18, then you understand how to get rid of your divide bys. But we just picked a bad value. It's too big. If I multiply everything by 6, then I can get rid of both of my divide bys. Because a 6 divides by 6 evenly, and a 6 divides by 3 evenly. I think you guys are maybe starting to see that that value that we're choosing here would really be the lowest common multiple. Really, for us, that's what you would pick to find your common denominator. So, hopefully, we're going to multiply everything by 6. Okay, everybody put brackets around every single term you see. And let's multiply them all by 6. Okay, we should all now have this on our page. Okay, what I want everybody to do is to go ahead and do what we did with the green in the previous problem. I want you to go ahead now and simplify each term. Anywhere where you have a divide by, let's get rid of that divide by. Okay, so hopefully we're able to go, hey, 6 divided by 6, that's just a 1. That's perfect. I have no divide by on the next term, and on the only term on the right side, my 6 divided by my 3 is 2. Okay, now I want you to take what you see on that screen in F, and I want you to write out your first line of your equation. Let's have every term fully simplified now. Okay, give it a shot. Okay, I'm hoping that I can catch up with you a little bit. There is nothing to multiply into that 7x. I have to multiply a 6 times the 2, and I have to multiply a 2 times a 1. Hopefully we have that blue equation, and I mean no joke, it should take you about 5 seconds to finish off that equation. Maybe 10. Like that is, our hand is maybe slowing us down on our speed. Our brain is going a lot faster than our hand can write. Because how do I get rid of a minus 12? I add 12. How do I get rid of a times by 7? I divide by 7. So hopefully we got down to that, and we are doing great. There you guys go. That's how we can deal with ugly numbers in the forms of fractions within our equations. Okay, this is where I say now, we want to be really good at working with this. Okay, I want to walk through G because there is a super common mistake that gets made on G. And I'm going to argue to you, if you have a full grasp of what we've been talking about over the last few lessons, then this shouldn't be an issue. However, if we haven't nailed down some of that terminology from before, G can cause you a real problem. Okay, I want to show you why. Okay, we take a look at G and we see a divide by 2 and a divide by 3. And pretty quickly, we're decent at going, hey, that means if I just multiply everything by 6, I can get rid of my divide bys. Beautiful. So then we go and we put brackets around every term, and we multiply everything by 6. I am hoping that you can see that I have just made a horrible mistake in question G. Like I just said to you that, hey, I'm going to multiply every term by 6, but I didn't do that. I actually multiplied one of my sides of my equation by 36. Now, my guess is you're probably piecing together that I'm talking about the left side, but maybe we don't understand why that was a multiply by 36. Look, you just put brackets around like both parts of it. And now I have to come back to, what does it mean to be terms? Remember, addition and subtraction separates terms. Multiplication and division do not. So when you take a look at the left side, and your original equation had 1/2 times y plus 2, how many terms do we have on the left side? Just one. That one term is something times something. So that is one term. It's an ugly term, but it's one term. Don't get distracted by this addition sign inside the brackets. If you had to follow BEDMAS, I can't do that addition first because I can't put y together with 2. Therefore, I would have to deal with the multiplication first. So all that term says is I have something times something. That's one term. So when I chose to go through and put 2 sets of brackets on the left side, and the 2 6s. I just multiplied the left side of my equation by 36. I multiplied both parts of that term by 6. Well, if I look on the right side, I multiplied the right side only by 6. I really just tipped my scale. That is a really easy mistake to make. That's why we're talking about it now. So what I'm going to do is I'm just going to get rid of everything that I had there and just rewrite out that problem. And so I think we've got our equation down, and now we should be good to go through. Okay, my decision to multiply by 6 was a good one, but I just need to put brackets around the whole term on the left to multiply by 6, and now the whole term to multiply by 6. And now that I have that, now I can go through my process again, and I think we can pick up the speed to do it. Okay, I can take my 6 and divide it by my 2, and there's my 3. And I can take my 6 and divide it by my 3, and there's my 2. Well, now what I have on the left side is I have 3 times 1, there's a 3, that I need to expand into my brackets. So I'm going to take that 3 and I'm going to multiply it in. So that's a 3y plus 6. On the right side, I have just a 2 times a y, 2y. Okay, let's go ahead and solve. And so if I put all my variables on the left side, I'm going to get just a positive y. That means let's get rid of the plus 6, we minus 6, and we are good. So we get down to a y equals negative 6, and we have a great solution to that. I would love to see you guys be able to solve equations that way. However, I do get that even after some practice, I'm going to have some people that are like, oh, Gray, I can't stop making the mistake of multiplying one side by more than the other because I'm goofing up on my number of terms. And I'm going to argue to you that if that's the case, then when you see an equation that is unsimplified like this one is, the left side, yes, it has one term, but you can see that you could expand those brackets to do some operations on that side. That maybe the line I would suggest putting in is expand in the 1/2. And I have no idea why I wrote 2y on the right side. Yikes. And now I'm writing it in red. So let's expand in that 1/2 on the left side. And let's get to that as an equation first. Now you do have individual terms. You can't collect anything. And now go ahead and say, hey, I'm going to multiply everything by 6. Notice the left side is now 2 terms. And so when I do that division, I can clean that up to 3 times 1 times y, 6 times 1, 2 times y, and you can see that we're just coming in on that same line, but one line later in our solution. Okay, I want to put a little pressure on you though. Try to solve it like the green method, that first way. Get some practice with it. We can use the blue method with that red line in there as a little bit of a default fallback. Okay, let's take a look at some more. Okay, so what you see on the screen is what we're going to finish off with today. That you have 4 equations. We're working with some that are relatively straightforward, maybe H and I. Those would have been hideous last time, but now those aren't too bad, hopefully. And then we work our way down to, pretty ugly in question J or K. Okay, what I want you to do is I want you to almost use this like a practice quiz. You keep going as much as you can. You try to knock out all 4, and then we see if we match up. If confidence is running really low, then maybe you're checking in again on just what question H looks like, making sure that we're on the right track. As you get more confident with it, I want you to try to solve more than one equation in a row without checking your answer. Okay? So your job is to try to get solutions to all 4 of those before we come back and we check. Okay, so give them a shot. Let's pause it now. Okay, so we should be coming back at the very least with H completed or something started and we're working through. Maybe we hit a snag. Okay, I'm going to go through fairly quickly on these ones. There should be an awful lot of confirmation in these solutions. Okay, we take a look. We notice that we have a divide by 5 on the left side. So what I can do is I can multiply both sides by 5. Therefore, my 5s will divide out on the left side, and we can then simplify what we have. Now, I would have some people that simply saw this divide by 5, since the left side was all one term, and they may have chose to multiply out to the other side. Great. In that case, we are going to get down to this. Expand in your 3, simplify the right side. So I'm going to have a 6x plus 45. That has to equal a 15. And now I am going as fast as I can go. So my 6x minus my 45, divide out my 6, and there we go. So hopefully we matched up. If you could show me that orange solution, that is great. Okay, we take a look at I. And we're going to actually get a little more confirmation now, not just from our Unit 1 discussion of ratios, but now with some equation work, why we may end up doing what we do in question I. Okay, I take a look on both sides of my equal sign and I notice I have a divide by 5 and a divide by 2. The number I can multiply to get rid of both of those is a 10. Why? Because 10 divided by 5 is 2 and 10 divided by 2 is 5. Now, I'm just going to write one more line in. This would not need to be a part of your solution, but we may just get further confirmation for why, when we have one fraction equal to another fraction, we can just cross multiply. Notice what we really did was multiply both sides by 10, but after simplifying, it looks like all we did was multiply the left side by 2 and the right side by 5. It looks like we cross-multiplied. When we didn't really. You can see in the green, we really multiplied both sides by 10. Okay, we get to that, and we should be good to finish. My overall solution, though, could just be take my 2 and multiply it in. And so we could jump straight to an 8x minus 2, and now take my 5 and multiply it in to a 10x plus 15. That could be your first line of your solution after we've simplified to get rid of our fractions. Okay, I noticed that my coefficient on my variable will be positive on the right side, so I am thinking about my variables on the right side. That's going to give me a 10x subtract 8x, which is a 2x. And that means I need my constants on the left. Negative 2 subtract 15 gives me a negative 17. And now to finish it off, divide out my coefficient, and there we go. So hopefully we matched up, and we've got a little more confirmation. We're feeling a little more comfortable dealing with equations with fractions. Okay, let's get to our doozies for the day. Okay, we take a look at J. J is looking uglier. I'm going to slow down for a moment. I see that I've got fractions, and I'm going to multiply every one of my terms. The left side is all one term because it's 1/3 times my bracket. Same thing on the right side. It's one term. So I'm going to multiply both sides by 6 to get rid of my divide by 3 and divide by 2. But I can simplify first, because 6 divided by 3 is 2, and 6 divided by 2 is 3. And now I can go ahead and I can multiply in and simplify both sides. So that's going to give me a 2 times y and a 2 times 4, and then a 3 times y and a 3 times 1. And very quickly, we should be able to think of our variables on the right side, because that's going to get me a y. That means my constants are going to go onto the left, 8 minus my 3, and hopefully we matched up. Nice. Okay, here we go. Let's finish up. Okay, you take a look at the big, ugly equation to finish. Okay, I look at all my divide bys. I need a divide by 3, a divide by 5, and a divide by 2. So that means I need a 3, a 5, and a 2 as the factors of my number. Well, 3 and 5 gives me 15. 2 gives me... I need to multiply everything by 30. Okay, so I'm going to put brackets around every single term. I'm taking my time to make sure every single term. That's one term, because those are separate. There's my minus sign, so this is another term. Now I'm on the other side of the equal sign. There's a term. I have 3 terms in that equation. Okay, we are multiplying every one of them by 30. But we're going to do the division first to clean it up. Because 30 divided by 3 is 10. 30 divided by 5 is 6. And 30 divided by 2 is 15. Okay, I'm taking a look at the first term I have now, and what that really is my 10 times my 2 times my bracket. So I can, if I want to, and if I'm feeling a little, not 100% confident, but maybe like 90, then maybe I put in that line where I just simplify my monomial. I don't have to do any work to simplify my monomial. Simplify my monomial. And we come in on the red. However, I would have a bunch of you that would feel pretty confident to put the 10 and the 2 together and expand it in one go. So we're going to take our 20 and expand it in. That's a 20x minus 20. Here's your common mistake. Take a look and notice that's a negative 6 that we have to expand in. You can see it in the red. So we make sure that when we expand that in, that's a negative 6 times x and a negative 6 times negative 3. And that's why we get the positive 18. Okay, on the right side, I'm now going to take my 30 and expand it in. So it's a 30 times x and a 30 times 4. Okay, that now becomes an easy one. If we didn't get to that point and we weren't correct to here, then I want you to pause the video and finish it off strong. Otherwise, we're going to now truck through. I think, as I've mentioned a number of times, that it's a good step to just go through and simplify both sides. Now I can see I want my variables on the right side. So that's going to be a 30 minus 14. That puts my constants on the left. That's going to give me a negative 122. And now when I divide out, maybe I put this line in as a comfort line. However, we should be looking to reduce, and we could see probably pretty easily that at least there was a 2 in both of those terms. And so if I divide out my 122 by 2, then that's a 61, and my 16 by 2, then that's going to get me down to negative 61/8 as my final solution. That was ugly. Okay, we had a big topic today. But I'm hoping at the very beginning you had a little bit of a practice quiz, so that gave you some good feedback about where you were on previous days' material. We got into some of the uglier equations where we see some fractions, but now we have some strategies to be able to go through and attack the fractions by multiplying out your denominators. Okay, probably more than ever, this is a big day for practice. So you work your way through, make up a great practice quiz, and we should be good to get good feedback on where we are with solving equations with fractions. Okay, jump in and play around with that practice. Best of luck.